This is problem number 4 in practice test number 6, and we are using the Poisson distribution again, and we have a practical application of that distribution. Your interest will be to calculate the value of the probability, which is the right hand side of this equation. We have the constant E, which is 2.71828 given here. And so then what we need is we need the lambda and we need the x in order to calculate this probability. The problem states that we should assume that the number of people entering a bank in 1 hour is distributed by a Poisson distribution. The mean lambda number of people entering the bank is 4.0 per hour. What is the probability that in any given hour, A, 0 people will enter the bank? So the lambda is given to us as 4, and we are interested in 0 people entering the bank, and x is the number of interest. X is 0 in this case, so we want to know the probability that 0 people will enter the bank. We're going to plug these values into the equation. The E is 2.71828 to the minus lambda as the exponent, which is minus 4. And then that's what we see right here in the first part of the equation. We're going to multiply that times lambda to the exponent x. Lambda is 4, and the exponent x is 0, and any number to the exponent 0 is always 1. So this value just becomes 1. In the denominator of the equation, we have x factorial. The x is 0, and 0 factorial is 1 as well. So these are two facts that you should remember, that 0 factorial is 1, and any number to the exponent 0 is always 1. So with these two values being 1, the only thing we need to calculate is this value right here, and when you use your calculator, this is what you should get, and we're going to round this off to the 4th decimal place. Section B of the problem asks, what is the probability that less than 2 people will enter the bank? The probability that less than 2 people will enter the bank is the probability that 0 people will enter the bank, plus the probability that 1 person will enter the bank. Less than 2 people means 0 people and 1 people. So we calculated the probability of 0 people entering the bank in section A. What we need to do here is calculate the probability of 1 person entering the bank. So we need to calculate the probability when x is equal to 1. So we plug into our equation. We notice that the e to the minus lambda, this is all the same as before because the mean, the lambda, is minus 4. So we're going to use the same value that we got up here in section A for this quantity right here. And that's going to be multiplied times lambda to the x, or lambda with the exponent x, which is 1 in this case. Now 4 to the exponent 1 is 4. And then in the denominator, we have x factorial. X is 1. 1 factorial is just 1. So what we end up with is this quantity times 4, which gives us this value right here, and we're going to round that to the 4th decimal place. So this here is the probability of 1 person entering the bank in any given hour. So the probability of less than 2 people entering the bank is the probability of 0 people entering the bank. That's the quantity we calculated in section A, plus the probability of one person entering the bank, which we just calculated. We add those together, and we get the probability that less than 2 people will enter the bank. Now, in section C of this problem, we calculate the mean and the standard deviation of the Poisson distribution. The mean is very simple. It's just the value for lambda, and the lambda was given to us as 4. The standard deviation of the Poisson distribution, sigma, is the square root of the lambda. The square root of 4 is 2, and we are done with this problem.